Now I'm going to go over how to find the equation of a plane given 3 points, and I'll show you an example using these 3 points. So in the previous video I mentioned, how planes can be defined by any 3 points that aren't on the same line, or by 2 vectors, 2 different vectors. So we're going to use these 3 points to make this plane, and as you can see, we'll kind of just determine that they aren't on the same line as part of this process when you convert these into vectors. So the vector to get to this, from this point to this point, the first, the second point, is 2, goes up by 4 to get to 6, and 3 goes down by 5 to get to -2, and then -1 plus 2 is 1. So this is the vector that takes that point to that point. And so next we have to find the other vector, right? From here to here, it doesn't matter which points we do, but we just want to do 2 different ones, of course, just because when we have our plane, we don't want to pick the same vector, right, to base our plane off of. It needs to be 2 different vectors, because 2 different vectors create that plane. Okay, so yeah, here are 2 vectors, and now we want to take the cross product of this vector. So why is that? Well, that is because, like I mentioned, whenever you take the cross product of 2 vectors, or just one vector, whenever you take the cross product, but usually you do it in 3D because it doesn't exist in 4 dimensions or higher. Whenever you take the cross product of 2 vectors, it will give you the normal vector to those 2 vectors. So what I mean by that is, let's say we have 2 vectors on this plane. Right here. This cross product will actually give us the vector that is normal to that, meaning perpendicular to both of these vectors. Okay, so that is really important, because if this plane is defined by these 2 vectors, and this vector that you get from the cross product is normal to these vectors, it's perpendicular to it, well then that means that this vector that we got from taking the cross product is also normal to that plane, right? Because the vectors are in the same 2-dimensional surface as that plane, so the cross product of these 2 vectors is going to also be perpendicular to that plane. Now, why is that important? It's because we always use the normal vector of a plane to find the equation of that plane. Actually, if we wanted to find, there's a really special relationship between planes and their normal vectors. Because let's say we had a plane with equation like 3x plus 2y plus 4z equals 5. Well, it's really, really easy to find the normal vector of this plane. It's just 3, 2, 4, okay? So you just take the coefficients of the terms in this plane, and that will give you your normal vector. So that's why it's so important that we find the normal vector of these vectors that make up the plane. So let's take the cross product, and so that's, remember, we put I, J, K at the top, and then we fill it up with our vectors, this matrix. We want to take the determinant, and remember, when we take the determinant, we want to cross out the first row and the first column, or whatever column in this case is corresponding with the letter that you're solving for. So in this case, I'm going to cross out the first row and column first, and it's just I times the submatrix of I, which would be -5, 2, 3, -6, and then don't forget we alternate signs, so we subtract J, cross out that row and that column, and we're left with 4, -5, oops, sorry, nope, that's why I just like crossing stuff out, and then, if you need to, if it's on paper, you can just erase the lines and keep going with your matrix, but 4, 2, 1, -6, and then plus, because now we're back to plus, K, the submatrix for K, when we cross this out, is going to be a 4, -5, 1, 3. Okay, now we're just going to expand this out, take the determinant of these submatrices, and we get 30 minus 6, which is 24. I trust that you guys know how to take a determinant by now. I don't want to write out all the steps, but 30 minus 6 is 24. I minus what is this? Negative 24 minus 2, so 26, actually negative 26j. And then plus, this is 12 minus negative 5, so 17k. And now our final equation for this is 24i plus 26j plus 17k. But this is an expression. It doesn't mean anything. We can take any point, not just these 3 points, and plug them into this expression. It doesn't mean anything. For this to be a plane, it has to be equal to something. So I want to just cover the different forms of equations for a plane. So let's just go down a bit. So first up we have the standard. I should actually probably move these points down. But I'll just talk while I do that. So first up we have the standard form. There's 2 ways to represent a plane. There's the standard form and then there's the general form. And I'll show you both of them. I actually do prefer the general form, which I think is kind of strange, since most people do prefer the standard form, because the nice thing about, there's nice things about both of them, but the nicer thing about the standard form is it allows you to, visualize your points pretty clearly. But I like the general form because it allows you to visualize your normal vector very clearly. And I will explain why in 1 second. So the standard form, I never remember this equation, but I looked it up just for you. The standard form of a plane is something like a x minus x naught, where x naught is just a point on the plane, plus b y minus y naught, plus c z minus z naught equals 0. Okay, that's your standard form. So the way we'd solve this, we'd put stuff into the standard form is this. These are our coefficients, right? This is the normal vector to the plane, and therefore these components are going to be the coefficients to the equation for this plane. So we'd write this as 24x minus an equation on this plane, which we'll say 2, okay? 2 is a point, 2, 3, 1, negative 1 is a coordinate on this plane. So we'll say this plus b, we have y minus y naught. Actually, the actual standard form for this would just be if we took this and we plugged in a, b, c as these. But I'm just going to plug in our x naught, y naught, and z naught just to show you what this actually means. So b, we have 26, y minus 3 plus 17, z minus negative 1, which is just plus 1. And again, I'm just plugging in those coordinates for this plane. So now, as you can see, this actually means something now, because this will equal 0, and when we expand this out, we get 24x minus 48 plus 26y minus, what is this, 78 plus 17z plus 17 equals 0. And so now we want to combine like terms, and we find that all of these constants, this adds up to, I feel so slow, it adds up to 109, negative 109. So we end up with 24x plus 26y plus 17z minus 109 equals 0, which you can write it like this, or you can also write it like this, equals 109. This is how this is how I've always seen equations for a plane, but I'm not sure. I think the standard form might actually be like this. In any case, I don't really think, unless your teacher wants you to write it a specific way. I kind of like this way because it just makes sense to me. And now this is actually your general form, or maybe when you subtract 109, it's the general form. But this is what your general form looks like. And as you can see, these coefficients are the same as the coefficients of the normal vector. And that is what I really like about this, because it just shows you, like, if you look at this plane and you're like, what's the normal vector to this plane, you can easily just be like 24, 26, 17. Not that you can't do that with this one, and in a way, like, you totally can, and in a way this is really nice because, it lets you see points which are on this plane. But whenever I write the equation of a plane, I always find myself going to this form, because what I always end up doing is saying, like, oh, this is the normal vector for that plane, so I'm just going to write 24x plus 26j plus 17k and set it equal to, whatever I get by plugging in one of these coordinates, right? So, we already did this point, so I'll just plug it in again, and instead of having to go through this formula, and, add like terms, all I'm going to do is just plug in x, plug in j, oh, I put j and k, whoops, plug in x, plug in y, and plug in z to get what's on the right side, right? Because we can just do that. So 24 times 2 is 48, 26 times 3 is 78, and 17 times negative 1 is negative 17. So we get that 24x plus 26y plus 17z equals, the sum of this, which you already said, was 109. And I just feel like this is a faster way to do it. And it's really nice and simple if you don't need the points to be shown in your equation.